Hello, I'm Robert, a fact checker and science blogger, and I help run the Doomsday Debunk group on Facebook to help people scared of various things. And I'm getting several messages and comments by people who are scared of this tiny asteroid called 2018 VP1. And if you look at it, the headlines look a little bit scary, and if you go to particularly if you go to the Daily Express one, then it sounds very scary from the title. NASA tracks a 21,300 miles per hour asteroid on a possible collision course, and NASA's asteroid trackers have revealed threatens to crash into our planet. This is just journalists using very vivid language. There's nothing scary about this at all. It's a tiny, tiny little asteroid. It is only 2.3 meters in diameter, a little bit bigger than a person. It would be like an astronaut coming back from space and hitting the atmosphere, and they would just burn up. Or like a spacesuit was thrown out of the ISS just as an interesting experiment some time back, and it just burned up in the atmosphere. And it'll just produce a fireball. And harmless fireball, and we get those very often. And it was first observed in the Mount Palomar. You can look up the observations. Also just show a little bit here about all this is done in the public. So if you go and search in my simplified search for simplified interface to the NASA database, then if you click there, you can show all the observations. You go here and show the observations, and it tells you it was first observed by this observatory. That's the observatory. This one here, Mount Palomar. This is the camera. And so all this is public. Everything is done in public. All the observations are done in public. Here they all are. Mostly by that observatory, and sometimes by a couple of other ones. And it's been seen since 2008. It's very well known. It's absolutely tiny. And they have a possible date of an impact on the 2nd of November 2020. But it's not expected to be hit then, because the odds against the date against a hit are 2,240 to 1. Now, unlike what the sensationalist press say, this is not because it can change direction. The changes of direction are very small on that kind of timescale of the next few months, and just the pressure of sunlight and things like that. The reason we don't know if it's going to hit is because we have very few observations, only for a year or so. And it's like if you were a golfer and you hit a golf ball with a golf club, and suppose you only had the first millisecond of the flight of the golf ball as it leaves your golf club. And then you're asked, will this be a hole-in-one? There's absolutely no way you can do that. No matter how good you can measure it, even if you can measure its position to a millimeter over that microsecond, it's not going to give you an accurate enough path to tell whether it's going to do a hole-in-one. You have to watch it for quite a bit longer, and then maybe when it's halfway through, then you would have enough accuracy to know it's going to go on the green and probably quite close to the hole. Only as it gets really close, you would have enough observations, not because the motion of the golf ball is changing, but just because you don't have an accurate enough measurement, unless you can measure it to fractions of a micrometer or something. But just with an ordinary photograph, you're not going to be able to tell if it's going to be a hole-in-one until it's really quite close to the hole. And so it's the same with these asteroids. We know pretty well where it was in 2000 when it was first observed. So if we go back there, it was first observed. Well, the earliest, these are pre-observation, so they often have that they observed it. It was first observed on the 3rd of November, up here somewhere, but it was actually some previous observations. These later observations through to the 16th. So it was observed on the 3rd, and then they continued to observe it through to the 16th. That's all they have of it, because it's such a tiny, tiny asteroid, and it only would be when it's very close to Earth that you see it at all. You can see here, this is the brightness, and they've got fainter and fainter and fainter Magnitude 26 is very faint, and after that they just didn't see it anymore. The higher this number is, the fainter it is. And at that size, until we have much larger telescopes, then we're just not going to be able to see it until unless it does a very close flyby again. So this is the best orbit we're going to have, and probably until then. And so, but if it is going to hit, then we have spacecraft that we have telescopes like the Atlas telescope that would probably pick it up again, and then give us some days of warning, even for a tiny thing like that. So we have had some examples of that, where we have had a few days of warning, or a few hours at least, for a tiny asteroid, and maybe for this small only be a few hours of warning. And then they've said, I think it's happened 4 times in the past, for very tiny asteroids, they've said, this asteroid's going to hit somewhere about there. And then people go and they actually do videos, and they actually see the fireball flying through our atmosphere, and pretty much where they predicted it. And this shows how good our predictions are. And if we ever had a big one, then they would be able to say exactly, it is going to go through the atmosphere just here. And especially if with the bigger ones, they'd have more warning. They'd be able to track them with radar as they get closer, and they would know days before, they would know the exact position to within a few hundred meters of where it is going to hit on Earth. They are that accurate. So that is why even if we had quite a large asteroid, if we knew about it in advance, then nobody's going to die of it, because they will say it will hit exactly there, and they will know that days in advance. And then this is if we're tracking them, and then they just say to everyone, get out of there, this asteroid is coming. Even if we can't deflect it, nobody will die of one of these asteroids. But this one is far as the ones that we're tracking. But this one is far, far too small. Nobody is going to die of this. Nobody is even going to be hurt by it in any way, because it's so small it'll completely burn up in the upper atmosphere as a bright fireball. And it's just a photo opportunity if we do find that it's going to hit Earth. Absolutely nothing at all to be scared about this asteroid. If you read these articles very carefully, then most of them do explain this. Some of them don't explain it so well, and some of them have a lot of nonsense in them. The sensationalist press often talk about say that we don't know if it's going to hit because the asteroid can change direction. That is not true. Asteroids can change direction very slightly, but not enough to make a difference. It is always this golf ball thing, that we only have a tiny, tiny little bit of its path, and with such a small, short segment of its path, we simply don't know its orbit well enough to know exactly where it will be on. But there's only one date that it can hit. It's the same way as if you hit a golf ball, then you don't know if you're going to get a hole in one. But if you time it very well, and knowing the gravity and so on, you could say to the millisecond exactly when it will hit the what you call it, the hole that the golf ball has to go into. You can say you would be able to say to the millisecond the exact millisecond when it would hit it, if you are going to have a hole in one, even though you don't know that you are going to have a hole in one, and it may end up in the pond or whatever, or in the sand bunker, or whatever they call it. But even so, you can say that if it does get in the hole in one, then you can say exactly when it's going to happen. It's the same with this. Then we don't know where it's going to be. It could be quite a long way away from Earth on that date of the 2nd of November at 1:12 p.m. But if it does manage this hole in one, and it does hit on that date, we know exactly to the minute when it would hit Earth, because there's only one place that it can hit. There's only one orbit, or a range of orbits all around about the same, that can get from that point to hit the Earth. It's just like the hole in one. There's only one place where it can hit the Earth on the orbit that it was on, and it is at that particular time, that particular date. And that is why you get these very precise times, even though we have absolutely no idea of whether it's going to hit or not, and we expect it to miss. I get a lot of people who are very confused by that. They don't understand how you can have such an exact time when you don't know if it's going to hit. And so hopefully this helps you understand that a bit better as well. And I'll put a link to this, to my simplified search here, and you can enter any asteroid name there, and it's just a very, very quick way of searching the techy tables, and it does it with, it shows everything in text and in words which are much easier for the ordinary people to understand. Although astronomers would not like this, because they prefer just very few numbers they can read in a second, and they don't need all these words of explanation. But for the general public, this is far, far easier to use, because it explains everything in ways that you can understand.